Hi, myself Sankalp, and I'm here to present what I had built in backend, and I made sure that I fulfill every requirement which was asked out of appliers. So I have made an image in Docker, and you can also run it up. The instructions are in the README file itself. So I have directly running it up since like 14 minutes or so. So we can test it directly here. We can test it via Postman, like I have already been testing each and everything from Postman itself. And so yeah, basically what is our architecture like? This is our architecture. This is a fault-tolerant webhook dispatcher. The Fastify API receives events and always returns 202 immediately. It never waits for delivery. A complete separate worker process handles all delivery asynchronously, like both run as independent Docker containers, like as you can see here. Like the API and worker both are separated already. The queue lives in PostgreSQL using for updates get logged. So I didn't use Redis or RabbitMQ. I used only a single database for everything, and that database is I used a clouds-based database which is Neon Tech. So yeah, let me go through the schema. It basically had tables of subscribers, events, deliveries, delivery attempts. The deliveries table is the source of truth, which is the one row per event per subscriber. So, so basically, how would we run? Like right now, if I start running it, it might take up some time, and I will not be able to complete the video soon. So here are some screenshots I had took when I was developing it. So yeah. So first I checked the help whether my database is connected or not. So my database was connected already. So first subscribe wasn't on my root part, so I did some debugging and yeah, finally it got subscribed for an event to and separate which will further store our event details. So here is our I have separated in a different port where we will subscribe. So the requirement one that is subscriber manage registration. So it required idempotency like same URL posted twice should return 200 with the exact same ID. The database uses an on conflict do update. The row is asserted but never duplicated. To support my logic, I had done this in subscribe.ts. So this was the main logic here I have written that the row is asserted but it is never duplicated. On conflict do update is the line. So let's see how I cater to requirement 2 and requirement 5, that is event ingestion and HMAC or the hexadecimal string. So back to our screenshots, each and everything was tested via npm run test. So first we had to turn on the mock receiver. So my mock receiver was in the harness folder receiver.ts, and to fire the event I put the data in raw JSON and I fired it already. So we can see that it is 202 accepted, and so the data will be received. So here we can see in our console that it is being received with booking ID and user. After implementing the HMAC policy, we can also see that signature is also being attached and it's being unique. So according to requirement 202 returned before any delivery happened, the fan out is completely async and every outbound webhook carries a SHA-256 HMAC. Now to the requirement 4, I actually don't have the screenshot right now. It's about if sequence 1 failed and sequence 2 and 3 are blocked, not independently like retrying, they are waiting for sequence 1 to succeed or go dead. So this is enforced by not exist subquery. So we can actually say this in worker dispatcher.ts. Here is a section of code where I had declared it already. Now the retry engine and the dead state of requirement number. So the requirement 3 was basically exponential. So requirement of week 3 was basically exponential back of like 10 seconds, 30 seconds, 2 minutes. So I had showed it via retry.ts in this file and I declared it already in this tuple. So every attempt is logged, HTTP status code response body truncated to 500 characters, and the latency is done as you can see in milliseconds. So the attempt log is append only and it can never be mutated. We can also see the screenshots for this delivery log thing. So yeah, here we can see we can replay first we can fetch the dead ones and then we can replay it already. So yeah, this is pretty much of what we have done. So the replay inserts a completely new delivery row. The original dead record is untouched. It's an immutable audit entry. The new row gets picked up by the worker within 1 second and retried from scratch. So finally the stress test, the main thing. So here we have run it already. Here is a live polling output. You can see there are 7 stable subscribers and 3 flaky subscribers, which have a possibility of 40% failure. So there will be zero duplicates, zero out of order. The guarantee holds under load. The Postgre here is used as a queue. This is a single system, asset transactions, no Redis, and there is not exist at SQL level partial unique index for replay, and X delivery ID header is being used. So and more detailings can be found in my folder on doc section where I have basically implemented all the phases of what I faced, what are the challenges, if we have faced any, if there are no challenges that I haven't written it. And then there was a final requirements audit where I have monitored if some deliverables have been missed by me and everything is documented while I was building the backend. So looking forward for the reply. Thank you so much.